Okay, so this is mechanisms with first step. So these type of problems, you have to do two things. First, this entire equation has to cancel to create the overall equation right here. This is the overall. And it does, because N2O2 cancels with the NO2 on the other side, and you're left with 2NO plus O2 and then 2NO2. Okay, so the first thing is complete. The next, the slow step has to have the same rate law as the overall. And right now, the rate law is not equal. So, but we can make it. So you look at the fast step, and then you see that it's a dynamic equilibrium. So if we write the rate laws for each of these, we can actually set them equal to each other. So the rate law for the overall is this, and they give you that. So then what you do is you write the rate law for the fast step. You write the reactant side, right? So it's NO, right? So you write K equals NO2, because these two are the same. You add them, and then the coefficient is actually the exponent. Because for elementary steps, these, like the overall step, it has to be given to you, but the elementary steps, it's just the coefficient. So you add these two together, so it's NO, and the coefficient is 2, so the exponent is 2. And then it's K1. And then what happens is it equals the second part of it. So we can write the rate law for the reverse reaction. So it's N2O2 times, we can write that as K negative 1, right? Is the K negative 1 is the reverse, and K is the forward. So what we can do now is, since they're equal, we can actually divide both sides by K negative 1, and we get this. We get that N2O2 is actually equal to K1NO2 over K minus 1. What can we do with this? We can substitute it into the slow reaction. So if we write this, we write the rate law of the slow reaction. It's K2N2O2 O2. This is not equal to the overall, so we can plug this in to make it. Because once we plug that in, and using this, K equals K2 times K1 over K minus 1 equals K, when we plug in our fast step, what we got into NO2, we plug it in, all these K's cancel to make K, the NO2 is left, and the O2 is left. And this is actually equal to O2. So this mechanism is successful because, first of all, it matches the rate law, and it cancels to create the overall chemical equation.